Good afternoon, ladies and gentlemen. Today you'll get an introduction to proportions. So by the end of the day, you'll be able to determine whether ratios are proportional, and you will accomplish this by simplifying ratios. We're going to go ahead and start with a video here. Let me pull it up on YouTube. This was originally in Nearpod. This is going to introduce to you what proportions are.
Welcome to Math Antics. In this lesson, we're going to learn what proportions are and how we can use them to find an unknown value. The good news is, if you know about equivalent fractions, then you already know a lot about proportions. To see what I mean, let's start with the simple fraction 1 over 2, or 1/2. Now let's look at a pair of equivalent fractions, 1 over 2 and 5 over 10. These fractions are equivalent because even though they have different top and bottom numbers, they have the same value. 1 is half of 2, and 5 is half of 10, so they represent the same amount. Okay, but to understand what a proportion is, we need to start with a ratio instead. A ratio is basically just a fraction that's used in a certain way. If you don't remember what a ratio is, you can watch our video about them. So let's imagine that a student who's a really good reader can read one book in 2 days. We could say that the ratio of books to days is 1 over 2. One book per 2 days. All right, but what if our student reads books at that same rate for 10 days? How many books would they read? Well, if they finish one book every 2 days, then in 10 days, they'll have read 5 books. So that ratio would be 5 books per 10 days. Do you see what we have here? These are equivalent ratios. Just like the equivalent fractions, they represent the same amount, so we can put an equal sign between them. When we do that, we have a proportion. A proportion is just two ratios that are equivalent or equal. And one thing that's really important to remember, in order for two ratios to be equivalent, they not only have to have the same value, they also have to have the same units. That is, they have to be representing the same thing on top and on bottom. Let me show you what I mean. This is a proportion because the top numbers both refer to books and the bottom numbers both refer to days. But what if we change the top unit of the second ratio to be pizzas instead of books? 5 pizzas in 10 days is not equivalent to 1 book in 2 days. So even though the numbers are still the same, this is no longer a proportion. Or what if we keep the same units and just switch them in the second ratio so that the days are on top and books are on the bottom? Are they still equivalent? Nope. This is not a proportion anymore either. 5 days per 10 books is not equivalent to 1 book per 2 days. So the units have to be exactly the same for both ratios to form a proportion. All right then, so a proportion is a pair of equivalent ratios. But
that's it. Proportion is a pair of equivalent ratios. When we're talking about proportions, we're talking about a pair of ratios that are equal to one another, that are equivalent. So let's go ahead and see how we will recognize if we have proportions or not. Now, in math, again, just to reiterate, proportions are equivalent ratios or fractions. Okay, so ratios do not have to have the same numbers, but they must have the same value. Here's an example here of many different ratios that are equivalent. These are all proportional ratios. They're all equivalent to, they have the same value as 1/2, though they do not use the same numbers. This one is 1/2, 2/4, 4/8, 8/16, 16/32, but they are all equivalent. They're all the same, so they are all proportional. So how do we decide if ratios are proportional? Well, we just simplify the ratio. If in their simplest form the ratios are equivalent, then they are said to be proportional. Here's an example here. Okay, so we have 10/18 and 45/81. Okay, So let's go ahead and simplify both of these ratios. Now this first one here, I can see is divisible by 2. I'm going to divide both top and bottom by 2, and I get that to be 5/9. Okay? Let's see what happens when we reduce this fraction here, this ratio here. Now I know 45 and 81, those both look like they could be divisible by 9. So dividing both top and bottom by 9, 45 divided by 9 is 5, and 81 divided by 9 is 9. And there we see that once we have reduced those ratios here, they are equivalent. Since they are equivalent, then we say that yes, they are proportional. Oops, we need an L on there. There you go. Take a look at this next example here. Same thing, we have two ratios, okay? These ones do not form a proportion. Let's look at why. Okay, again, we're going to reduce both of these fractions to their simplest form. I see that both 12 and 9 are divisible by 3. I was thinking that we're going to get 4 right there, and 9 divided by 3 is 3. So this reduces to 4/3. How about this here? Again, they're both divisible by 3. 15 and 12 are both divisible by 3. But does it reduce to the same simplified ratio as 4/3? Well, 15 divided by 3 is 5, and 12 divided by 3 is 4. And right there, we see that they are not the same. They are not equivalent. Therefore, they do not form a proportion. So let's take a look at these ratios. Now, these ratios are just laid out with a decimal. So what I'm going to do to start with here is to rewrite these as in like fraction form, right? So 19/16 and 12/10. Let's see here. Let's see if these are proportional or not. 19/16. Now 19 is a prime number. That means that the only numbers that go into 19 are 1 and itself. So this one's already reduced. And I can tell you already this one's not going to reduce any further than this, right? It's not going to look like 19/16. We can divide both top and bottom by 2 just to check here. And we find out that we end up with 6/5. Now 6/5 is not equal to, it is not equivalent to 19/16. So this is not proportional. These ratios are not proportional. Okay. One more example here before you guys get a whack at this. Again, you can see that the ratio is set up with a colon, so it's set up horizontally here. I'm going to take that and I'm going to just rewrite it so that it is set up as a fraction in fraction form here. So 21/7, 15/5, and let's go ahead and see what we get here. Okay, again, I'm just going to reduce both of these fractions here. I see both 21 and 7 are divisible by 7. So 21/7 reduces to 3/1. That's great. Let's go ahead and take a look here. Both top and bottom are divisible by 5. 15 divided by 5 is 3, and 5 divided by 5 is 1. So in this case, yes, it is proportional. These ratios are proportional because they are equivalent, right? These are proportional because these two ratios are equivalent. So these ratios are proportional. Because they are equivalent when they reduce down. Go ahead, I'm going to have you practice these here. Let's start with number 1. I'll label them. So go ahead and start with number 1 right there and see if you think that is proportional. All right, 1/15 is already reduced, so we can't reduce that any further. And 2/3 is also already reduced. So those are already reduced. They are already simplified. They're in their simplest form. So are those equal? No. So is it proportional? No. Go ahead and try number 2. All right, we have 3/4. Again, that one is already reduced. Let's reduce 9/12. Well, 9/12 can be divided top and bottom by 3. And we see that that reduces to 3/4. So are those two ratios equivalent? Yes. So are they proportional? Yes. Go ahead and try number 3. All right. Now these ones again are laid out horizontally. So I'm going to start by making them vertical. 10/20, both can be divided by 10. We end up with 1/2 right here. Both can be divided by 2. We end up with 1/2. Are those ratios equivalent? Yes. Are they proportional? Yes. If they are equivalent, if the ratios are equivalent, then we say that they are proportional. And lastly, go ahead and try this last one here, number 4. All right, taking a look at number 4. 15/7. 7 is a prime number. We cannot reduce that any further. 7/6. 7 is a prime number. We cannot reduce that any more. Are these equal? No, they are not equal. Are they proportional? No, not proportional because their ratios are not equal. All right. We already looked at that one. I just separated these. Okay, so you will also be looking at these word type problems, okay, where they're giving you these ratios in context of something. And you'll be asked, do these ratios form a proportion? So all we need to do is take this information from both of these, set up our two ratios, and see if those ratios are equivalent. Let's take a look at the first one here. We have 9 old binders to every 8 new binders. 9 old to 8 new. Okay, at this point I cannot simplify this ratio, right? I can't reduce it any further. Let's go ahead and take a look at this one. 20 old binders to 15 new binders. This one I can reduce. I can simplify this one. I can divide both top and bottom by 5. And I see that I get 4 old binders to 3 new binders. So are those equivalent? Are these two ratios equal to one another? No. Are they proportional? No, not proportional. All right. This one we're not going to do. This is just bigger numbers. And you'll see I've changed the requirements. A 70 is equivalent to 100. So you shouldn't get to too big of numbers like this. What I want to know is, can you figure out if these ratios are proportional or not? Go ahead. All right, let's see. Are these two proportional? Let's find out. 5/4, I'm just going to 5 customers to 4 hours. Okay, that cannot be reduced because 5 is a prime number. And let's go ahead and see if 20 customers over 16 hours is equivalent to this ratio. Okay, we can divide both top and bottom by 4. And I find out that 20 divided by 4 is 5 customers. And 16 hours divided by 4 is 4 hours. So are they equivalent? Are these equal? Yes, they are equal. So are they proportional? Yes, they are proportional. Yes, proportional. All right, one more practice here for you. Try this out. All right, let's work it out here. Again, I'm just going to take each of these pieces of information, write it in a ratio: 14 full-time employees, 6 part-time employees. Oh, that should be full-time and part-time. Just erase all there. So here we go. 14 full to 6 part. Is that ratio equal to 18 full and 12 part? Again, we're just going to reduce both of these fractions here, both of these ratios, and see if they are equivalent. Both 14 and 6 are divisible by 2. And we get 14 divided by 2 is 7 full-time employees. 6 divided by 2 is 3 part-time. Let's see if we get the same thing over here. We're going to divide both top and bottom by 6. They're both divisible by 6. And we get 18 divided by 6 is 3 full-time. And 12 divided by 6 is 2 part-time. So we find out, sadly, that these two are not equal. They are not equivalent. So they are not proportional. Not proportional. Wah, wah, wah. And that's what you're up against today. You're going to be looking at J12, okay? A SMART score of 80 is 100%, and you are welcome to use a calculator on this. Some of those numbers get a little bigger, and I don't expect you to know all of the factors of those numbers. So go ahead and try that out.